Welcome back to the channel. Today we're gonna see the difference between ground speed and true airspeed. Let's go! So let's start with the definitions. Ground speed is the speed relative to the ground. It represents how quickly you are covering distance over Earth's surface. If we move to through airspeed, we have the speed relative to the surrounding air mass. So for example, if this is the section of our wing and this is the airflow, true airspeed represents how fast the air is flowing over the wing or the canopy. And true airspeed depends on air density, which decreases with altitude and temperature. This means that the true airspeed is higher at higher altitudes for the same indicated airspeed. For example, at sea level, if we have an indicated airspeed of 100 knots and a true airspeed of 100 knots, at 10,000 feet, the same indicated airspeed could correspond to a true airspeed of 120 knots due to lower air density. So, ground speed tells you how fast you're moving over Earth, and true airspeed is telling you how fast you're moving through the air, and it doesn't depend on the wind conditions. So let's move on, and how can we measure each one of these two velocities? So for ground speed, the usual instrument is a GPS. So we track position over time. The GPS, in fact, calculates your speed relative to the ground with high precision. It's really accurate and it's independent of atmospheric conditions. While if we move to the true airspeed, a classic instrument is the pitot tube. Have you ever seen this one? So this is a system where we have a pitot tube and a static pressure system. So in here, we are measuring the dynamic pressure like this. So we know that the total pressure is the combination of the static and the dynamic pressures, where the dynamic pressure is the combination of density and velocity. So, in other words, if we want to find the velocity, we have to measure the difference between the total and the static pressure in this configuration, divided by the density of the air itself. Just to give you a reference, these kind of instruments are the one that you can see in the nose of the plane when you're boarding your plane at the airport. To calculate with a pitot tube the true airspeed, we also have to make some kind of correction based on the altitude and temperature, but that's not the point of this video. Anyway, if we want to measure ground speed, we use GPS, and if we want to measure the true airspeed, we can use a pitot tube. Yeah, cool, but which one of these two speeds matters for wing or parachute performance? So when we want to evaluate the performance of our wing, true airspeed is the critical measure we have to look into. Why? Because first of all, the aerodynamic behavior, so metrics like lift, drag, glide ratio, depends on relative airflow over the wing surface, like this. And the true airspeed reflects this concept. When we want to evaluate the performances like lift and drag, we have to take into consideration the true airspeed. So, in the case of an airplane, what we want to measure is how fast the air is moving through each section of the wing, the fuselage, and all the other parts of the plane itself. Yeah, it's true. Ground speed is also useful because it gives us information about how long is gonna be the flight. For example, if we have any kind of rough weather condition where we have a lot of wind, etc. But to understand the performances of the plane, so in other words, how safe is the plane, we gotta know and we gotta measure the true airspeed. Another example is canopy. So if you're flying your parachute and you want to know the glide ratio of your parachute, You've got to know the true airspeed, not the speed you're moving compared to the ground, but the speed you're moving through the air. So that, in other words, that means how efficient your canopy really is. So, while GPS-based ground speed helps you track your movement relative to the ground, like this, the true airspeed provides the accurate measure needed for evaluating the performances of your plane or your canopy.